Good afternoon, everyone. Welcome back once again to our blockchain development bootcamp with God's power. So let's just get into activity. We'll continue from where we stopped on Thursday. So, over to you, God's power.
So hi everybody. Once again, my name is Gospa. I'm a video, I'm a blockchain developer and a front-end developer. So today, last class, we're talking about the basic structure of Solidity, data types, and so many other stuffs. So today we are going to be entering more deeper stuffs. For example, we are going to be talking about the smart contract fundamentals, like the contract structure, how a contract is structured, if life cycle. What you mean by life cycle is how the processes that a contract uses, how a contract is being moved, a life cycle, just like metamorphosis, a life cycle of a mosquito, how a program is created, executed, and that we're going to be talking about state variables and functions, which I did. So I'm going to cross that out. I'm going to talk about constructor and fallback functions. I'm going to talk about events and logging, and we're going to talk about handling errors in Solidity. So we are going to start with a contract structure. So I once said a contract is like an agreement between two parties within the blockchain. So um they execute transfer by themselves automatically. So when we mean by a contract structure, imagine you want to cook soup, any soup that you want to. Those ingredients in that soup are called variables. What to use to do ingredients are called variables. We have another the steps to execute this contract are what we call functions. Now, your contract structure can consist of um, a an ingredient which is a state variable and a function which is your steps. So we'll be talking more on the life cycle, the movement, how a contract is being made, how a contract executes, how the end cycle of a contract, and so many other stuffs. So many other stuff. So stay with me. I will show you a lot. Now, let me start. Let me open my file. Let me open my file. So I'm going to be showing you that three steps in contract life cycle. If you created a contract, there are three steps in a contract life cycle. One is the creation of the contract. When we say creation of the contract is, for example, now this contract called Lecture 5 is the creation of that contract. And this is what it is being deployed. The name of that contract is what is being deployed, which is Lecture 5. Now, the second step is execution. So when you execute the contract, the user can now talk with the contract by using functions, by calling functions. So I told you what a function is. A function is like your body part that you tell it, please move, and it moves. So the next step is what? A completion. So after a successful execution, the end product is always completion. Has this contract finished running? So has it ended? So that is what the contract life cycle involves in. It consists of both the creation, execution, and completion. Now, I'm going to talk about state variables, and I told you what a state variable is. So, a state variable is more like a memory in your computer allocated for a specific data type. Told you what a data type is. A data type is like the unique attribute of your variable. For example, my name. The data type for my name is what? A string. So, let's say if you wanted to create a smart contract for a piggy bank, like for a piggy bank or saving, the state variable that you're going to be using is what the balance, which is what the ingredient that is there. For you to have a piggy bank, you must have a balance. Is it zero? Is it greater than zero? And you must have what to you deposit that money inside it. So a bank, let's say a piggy bank, we have a smart contract called what? Bank. And then uh, the bank has this thing a name, a function which is used to deposit money, like just like your OP. You can deposit money, which is that function. You can withdraw money, which is the function. You can also the state variable is your variable, this is your balance. So hold on. hmm So, so I've talked about state variables and functions, how it works, how the life cycle of a contract. We have the completion, we have the execution, we have the what, the creation. That's the three main reasons. Now, the next one we are going to talk about is constructors. I told you we are going to enter constructor. Today's lesson is going to be brief and short. So, let's say we have, let's say we have, I should even do an example of the life cycle. Hold on. Hello world. Let's say return greeting. Let's say returning greeting. Let me show you how a life cycle works. And so you have a contract called what? Hello world. So in this hello world, it has a greeting, which is the creation. The creating is smart contract called what? Hello world, and it's going to contain a state variable, which is what the greeting. And say greeting is called is going to be the execution, and the completion is when we return this value greeting. So let me deploy it. Deploy. Now have you seen it? We have deployed, which is it has been created. Now if I say greeting is going to return hello world, this greeting is state variable, which also hold what? Hello world. So if you understand that, now let's go to the constructor. So what is a constructor? So when I was in school, I was told the constructor is a special function that runs only once and is only created once. So it is used to, like, for example, just like in the struct, the data type that I told you is used to give more details about a contract owner. So a constructor gives more details about that contract. For example, now, um, I have a contract called Hello World, and I on that contract, to give me brief description of how that contract is. The constructor helps you to know a brief details of that. For example, now we have a what, a donate contract. Let's just say we want to do a donation contract. Let's just say donate donate contract. This donate contract is used to deposit, like donate to a given this thing. In that donate contract, the properties of a donate contract is the state variables that we need. When I say state variables, what they are the important features the donate variable must have. Must have an address where I'm going to donate the money to. Public. Public is used to tell the listener that I want it to be open for everybody. And we have the owner, the person that is depositing that money. And we also have a constructor. So I was talking about constructor. So the constructor runs only once when the contract is being deployed. Constructor. Constructor call what? Address. This constructor is going to hold the address of what the recipient when it's being created, which is the owner, and the recipient is anybody. So a constructor is more like a function, but it only runs once. Only runs once. What do I mean by one side? So it gives a brief details of So you give a brief details of what we want to use here. So a constructor is telling us now that yes, in this my contract, we must always have what the owner, which is the person that is going to send the money, and the recipient, the person that is receiving the money. So that's what it means. Let me run it. Deploy. Mhm. Okay. Let's say the address of the recipient is what? Yeah, copy. This is the address of the recipient we are putting, and we deploy it. Now, do you understand what just did now? Before you deploy now, the contract is looking for the person that's going to be receiving that money. So we just say deploy. Now, if you look at it, now it automatically stores the address without it acting as a function. Before you deploy, it asks you, please, we are going to run this one, so please, I want to get the recipient address. Now, you check now, the recipient address will be the one that I inserted. The owner will be the person that deployed that contract. Have you seen? So if I want to send money now from the owner to the recipient, it is very easy. I will not get into that because that was not today's topic. So we are going to be looking at how to perform these donations. I'm coding a simple donate contract. I'm trying to show you how a constructor is working. Then I'll show you now. Now, if I wanted to donate a contract now, I'll just say donate a public. And why I mean public? Because this donate I want it to be open and can be accessed by other function. And Solidity has something what we say payable. So when it means payable, I can transfer funds from my owner to the recipient. And for you to transfer funds, you can use the call value we have to transfer. We have call, transfer, and send. But they always recommend call. But I'm going to be using um, more like transfer to the wallet. But since we're not doing that, I'm going to show you how to allow donations. So for now, we said require. Require is like more like telling you please. It's just like a modifier. Taught from the curriculum, it's like you were taught what is a modifier. A require tells you please. If this is just like an if statement, if it's not greater than zero, you must have what? Must have some ETs or ETH. Have you seen? Now, and emit is when you are creating the event log. So I'll do that later where I'm talking about event logs and everything. So I've shown you how a constructor, what is a constructor, a state variable, a function, and this is, so we are going to be entering event logs. So events are like should I say, for example, events are like what notification we and you when you get from your distance. That's how Solidity works. Their own is notifications. Events are like notifications where you are actually calling from external application. For example, now I want to buy a car. Should I say car? A car? Now I bought that car and kept it in my house. So for me to allow other people to be able to see that car and buy it online, I'll create an event which is I emit it later. I emit the event so that people from the outside world can call it. So just like in blockchain, just like in blockchain, before you emit, you must have an event that you're emitting. So the event is what is happening that I want, and the emit is telling me, please, if that event occurs, please shift it out. Now, so let's say you're having a smart contract called a message board. When important something happens, like for example, that message board in your school, you have where you can write, where you see notification of what is going on, your result and everything. So the outline notification, like they are telling the outside world, this is what is happening in my contract. Now, for the event, for example, now we have a lower event, let's say an event, we create an event called what created, which is going to emit an address, let's say an address, the sender, whosoever is sending that this thing, and the message that the person is sending. They just say, yeah, this is the message. Now I'll create a function. The function says what? Say hello world. We have public. And let's say we are emitting in this function, we are trying to emit the say hello world event. But yeah, the created event that happened there. And we say the address of the person that is sending, which is the owner of the address, and the text hello. So now if I run this, if I want to run it now, we deploy it, compile and run. So we want to deploy it now. We say we add our recipient here. And we deploy it. Now you see here that the events will be logged out here. Let's say so. Have you seen now? We have the person that was saying we emitted an event here. The address recipient, the person that has this address, which is the owner.
Hello, hello, hello. Are you there? Okay, we'll be back in a few minutes. Just hold on for us. Okay, so we are having a little network glitch, but we're back. We'll join you guys again. We're having a little glitch from the network, so we'll be back very soon.
So can you hear me, everyone? I'll have to wait
Yes, we can
till
hear you.
everyone. Okay,
Can hear
please,
you.
where do we stop?
Welcome back. Um, I think I missed. You were talking about what was this thing called? Log or okay, you said you touched the log later. I think I missed that part.
Okay, okay. So I'll start from the login. I said login is more like you're trying to, it's a permanent record on the blockchain. For example, after you have emitted an event on the blockchain, you'll be able to see that emitted event, which is permanently recorded on it. So why do we need this login? So this login is used for visibility transparency for everybody. Now I showed you here the logins. These are the login for the logs of the function that I just did. Now, for you to have an log, you must have an event. You must have what is triggering that event. You must read that log. So logging allow for you to see everything about that function. So about that function and this thing. So in real world cases, logging allows you to have transaction tracking uh, for the user to perform some actions and error reporting. We're coming to error handling and reporting. So the transaction tracking in the Bybit uh, hack that happened that has to do with the multi-sig wallet, where the code wallet, when they were trying to transfer money from the code wallet to the hot wallet, and the guy was imitating as Yanka was imitating as a like the name, but the smart contract logic was different. So it diffused the fund to his own address. Now, Zach, a blockchain investigator, was able to track the funds, even and locate it to, he said, North Korea, but sorry. He was able to that funds funds to a certain address, and this address was splitted. It was splitting the money into 39 addresses as you have the correct record. Now I can go there, go to the blockchain and see the log of what was happening there, how the transaction is being moved, the live transaction. That is called transparency. I can see everything. I don't have to hide. I don't have to compromise and say yes, the phone was not moved when I'm saying it. So that's the function of logging. Now we will talk more on the next one. Next one was I was saying was not going to take time. The basic, yeah, error handling. Error handling is very essential in our everyday life. So error handling in our everyday life, like you want to get something and something happen on the road. Do you have a contingency plan? That's what error handling means. So every language has error handling, how error are being handled, and how you handle that error is one essential thing, and how you fix that error without allowing the error to cause other bugs on the system. So error handling solidity, we have different type of error though, and the true exceptions, the we have a lot, but definitely I'll be sticking with error handling solidity. So error handling in solidity is like, which these are rules which prevent mistake in a smart contract. So instead of if something goes wrong in that smart contract, the error pops out and stop that transaction. That is what the error handling men do. So in order for us to do error handling, we use require, we use revert, and we use assert. So require helps you to perform an action or stop the function if that action is not met. For example, I said in here, I said if, let's just say required, should go back. Yes. I said, now I was saying, I'm requiring that in this an error handler, but if if value of my money, it is not greater than, is it greater than zero? If it's greater than zero, then I must have what? ETH, which is I have an ETH, sorry. If it's less than zero, let's say. the value in my balance is less than zero, it means I must have an ETH. I must have small money before I can perform a donation. That is what it means. So they require stop a function to that function meets all the requirements. So the next one is revert. A cancel, like in the revert is more like I'm performing a transaction, I'm trying to transfer money, and if an error occurs, please go back to an initial state or through an error. For example, now let's say I want to I want to force fail, like we have a force fail safe, let's just say. What a force fail safe is like more of, like let's say we have a function that whenever I click it, it forces the function always fail. Now the revert is telling us this function, when something happens, please, this function will always fail. Please return back to an initial function. That is what revert always means. Let me deploy it. Let me remove this. So let's say first fail. Let's look at the log. Now they say the transaction have been reverted to the initial state. Why is this so? It's because we use revert statement, and this statement is telling us the function will always fail whenever we click it. Please, we are going to go back to the last transaction. So that is what revert always means. So let's look at the assert. Yes, the assert is more like used for more complicated stuff. For example, now we want to debug for critical issues. Let's say we want to check the owner of an address. Is it the person? We want to check even the owner of an address. Is it always empty? So let's say, let's say we want to check the owner. We say, as I please check the owner, the address. Is the address empty? That's what it means. So if the address is empty, let's say if the address is not empty, say hello, return. String hello. Let's say we want to deploy it now. Let's say it checks now. So it has been reverted because the address did not hold any. Okay, it ensures that like now it's reverted because the address has does not have an empty address. So if the address was empty, it could have shown. Let me check something. Okay. Mm-hmm. Let's deploy. Yes. The first one is checking, does the owner exist in an array of address? If yes, so please return hello. But the other one was checking, please check if they an address is this address inside that address? Is the address empty? Is it equals to that address, the first index of an address? It says no, it throws that error. So have you seen it now shows all the log of what is happening here? You can even debug it, everything that happens. So that's more of error handling. So the first one a require stop the transaction from what happening to a require to all the requirements are being made. So the next one is what revert is telling you please force a failure with an error message. So that's what revert is saying. Say ascent now is telling us if something is seriously wrong, please, if it fails, something seriously is wrong. So asset is used to show the critical level of that error. So why do we have to use error handling? We use it for what? To prevent the mistakes of maybe sending wrong zero ETA, you're sending zero, stop unauthorized access and save gas fee. So I think that was for today. Everything for today that I do have to teach because I was not able to complete it yesterday. I hope if there's any question we can actually try to hit it up in my DM. Um, Hi, Damilara. Are you still there? Hi, Damilare. Are you still there?
Yeah, yes, I'm with you. I can hear
So,
me.
yeah, I'm kind of done with the topics. I'm actually
Okay.
done for today. So,
Yeah.
I think that was all for today.
Okay. All right, so guys, thank you very much for joining. That will be all for today. If you guys have questions, I would really love you guys to reach out. Or you can drop a message in the comments. I see answer Lillian. I think yeah. If you are trying to ask a question, you can drop it in the comments, or you probably in the Discord channel as well. So um, we have covered. This is supposed to be our week 3, and we have covered everything on week 3. We will also be sharing our resources on the Discord channel for if you have missed them so far. So from next week, I think maybe I should just talk about what we'll be doing next week. Next
Okay.
week, yeah. So we will prepare our minds toward it. What do you think, Jip?
Next week is actually kind of good though, but I'll
Yeah,
be preoccupied because next week is more of advanced solution concept. I could
yeah.
take from upper week then. It's week 5. I could take from week 5.
Wait. We'll discuss about that later. I just want to build that on
Okay.
the topic. So we have advanced oriented concepts, inheritance and interfaces, libraries, abstract contracts, state implications, and gas optimization. So that's most of what we'll be having next week. That's will be Thursday, 7 p.m. and Saturday, 12 noon. So thank you very much for joining today's session. Thank you, God's Power, for taking your time.
Thank you.
Uh, have a great day, everyone. I'll see you next week.